And we're live.
Great. Hello, everyone, and welcome to the second live session of today's social media event, Being Human 2.0 Synbio Live. We hope you enjoyed the first session. Hey, did you guys get to tune in? What a great chat with Professor Hecht, yeah?
Oh, totally. It was really neat how much he clearly thought about the philosophical implications of his work.
I totally agree myself. But in any case, now it's time for our second session of the day. And well, if you've ever listened to one particular science policy podcast on SoundCloud or iTunes, I'm hoping the three of us sound a little familiar. So let's try this. Hello, everyone, and welcome to The Forum, where science comes to socialize, the official podcast of the Institute on Science for Global Policy. There, sounding familiar now? So I'm Aubrey, and I'm joined today by my co-hosts Cleo and Daniela, and we are the co-hosts of ISGP's The Forum, a bi-weekly podcast on science and society issues hosted by, you guessed it, the Institute on Science for Global Policy. We also happen to be one of the groups convening today's Synbio Live event. Today's podcast, though, will be a little different than anything we've done before for two big reasons.
Yeah, well, now you can see our faces, not just our voices. And we're also coming to you live.
Which means if any of us has a laughing fit, or if we start sounding kind of robotic because of the internet, which happens about 9 out of every 10 times we record, I can't edit it out. So you've all been warned.
Nah, we'll be fine. It'll be great.
So despite these novelties, two things have not changed. First of all, Daniela and I are, of course, over the moon about our food-related topic for today. And second of all, we still want you to be interacting with us on social media. So tweet us your comments and your questions during today's episode. And don't forget to use the hashtag SynBioLive.
So let's get started, shall we? Today's live episode of ISGP's The Forum will discuss a topic that, well, if it wasn't included in this virtual workshop on synthetic biology, I'm really not sure what kind of credibility our workshop would have. The topic, of course, is GMOs, or genetically modified organisms. Today, we'll discuss genetic modification of plant-based food products in particular. But do remember that engineering the genetic material of a living thing is not just limited to canola or corn. For instance, you might have heard about genetic engineering of mosquitoes or other pests. It's not just a possibility, but it's something that's gained a lot of attention in recent years.
In this episode, we're going to aim to cover three big areas mainly. First, Aubrey's going to lead us in a discussion of the science behind GMOs, and then we'll start putting the forum's classic policy spin on things by giving you an idea of the international GMO regulations. Daniela is going to help guide our conversation on that, as the co-host located outside of the United States.
And then we'll end with Cleo leading our chat on more recent GMO label laws, especially the ones that were all over the US news in 2016. So we've got to start somewhere. Aubrey, do you want to take it away, seeing as you're a resident scientist?
Surely. So I guess it's pretty important to define what a GMO is. What is the purpose of genetically modifying an organism? Well, in essence, what scientists are trying to do here is to achieve an organism having a certain characteristic. And we'll get back to what some of those characteristics might be in another minute or two. But for now, let's first understand that we can usually use one of two different methods to get a product with some characteristic of interest. The first method is called conventional breeding.
And in conventional breeding, the breeder, being plant biologist, farmer, or whoever, finds individual plants that happen to have the characteristic they're looking for. Then he or she pollinates one of these plants with the other, isolates the spawn that have the good characteristic, breeds those plants, isolates the new spawn,
etc. The entire process basically takes forever.
Yeah, there's a significant time investment when it comes to conventional breeding, and that's really where genetic modification comes into play. The terms genetic modification, or you might see the acronym GM, or even genetic engineering, GE, they sound kind of freakish, but in practice, they're really just accomplishing the same thing as conventional breeding in an unconventional way. You see, plants are built, so to speak, using a DNA blueprint just like ours, and their DNA contains genes. Your genes, or Cleo's genes, or Daniela's genes, define traits like eye color and height, and a plant's genes define traits like flower color or type of root system.
These traits, or characteristics as we've been calling them, are the types of things that we can change in a plant with using genetic modification.
Right, and genetic modification lets us skip the super long process of conventional breeding by straight up deleting genes that do things we don't want, or by adding genes that do things we do want.
And when it comes to adding genes, a lot of people worry about things like, oh, what happens if we put a peanut gene into a tomato and make everyone allergic to tomatoes? And although I guess that'd technically be possible, that's really not what food scientists and biologists are going for here.
Yeah, on the contrary, the types of traits we're looking for are more practical ones. So things like drought or heat tolerance, pest resistance, higher yields, extra nutritional value, or the removal of allergens.
And it's really this potential to provide higher crop yields, or really any yields at all, in less than ideal conditions resulting from factors like climate change, that has experts saying that GMOs could be a solution to food security challenges, especially in the context of one of our favorite forum statistics.
Oh, you mean the projection that the global population will reach 9 billion by the year 2050? So yeah, we might benefit from having a range of solutions to feed the tons of mouths of the future.
Yeah, so it's probably pretty intuitive to think about how traits like drought resistance and added nutrients could help us in a food insecure future. But where do these helpful genes actually come from? It turns out that many actually come from bacteria. For instance, a gene from the soil bacterium Bacillus thuringiensis can be used to protect plants from common pests like rootworms and caterpillars, while a gene from Bacillus subtilis essentially trains plants to use water more efficiently when faced with drought stress.
So I'm not even looking at Twitter right now, but I would think that some listeners might be wondering whether that means eating a crop modified with a bacterial gene is actually kind of like eating the bacterium itself.
And the answer is not at all. Remember when Aubrey mentioned that plants are made up of the same type of DNA as us? Well, living things in general are made up of a common so-called ATCG genetic code, meaning that your cells, the bacterium cells, and the plant cells all contain DNA made up of the same molecules. The molecules are just organized in different ways. It's kind of a case of you say tomato, I say tomato, but I've never actually heard anyone say tomato. So.
Nobody says tomato. Anyway, so now the plant has a new gene it didn't have before, sure. But it's not like it has some new genetic material. Wait, guys, can I use my Jersey Shore analogy?
Oh, I'd really prefer you didn't.
Too bad we're live, I'm doing it. So let's just put it this way. If MTV taught me anything when I was a kid, it's that the culture of the Jersey Shore is probably pretty different than somewhere in, say, the American Midwest. Now, let's say for some weird reason, we wanted to introduce orange spray tans, big hair, an exaggerated New Yorkish accent to the Midwest, so we took a cast member from the show Jersey Shore and transplanted them in somewhere in Nebraska. That doesn't mean we've made Nebraska into New Jersey by any means. I mean, we're still missing the ocean, the boardwalk, Six Flags, but now maybe we have a salon specializing in hair poofs and fake tans.
As much as I hate to admit this one, that's not like the worst analogy in the world, especially because you've effectively called DJ Pauly D a bacterium. And for those of you out there who don't know what we're talking about right now, consider yourselves very lucky. It's a pop culture reference that I personally wish I was not privy to.
I love Psychom.
Oh, geez. So this whole live podcast thing really is not conducive to coming up with seamless transitions from DJ Pauly D to GMO products in the marketplace. So with absolutely no shame at all, I'm just going to switch gears. So you, our listeners, might be wondering at this point whether or not you've ever come into contact with GMO foods before. And the answer is almost assuredly yes.
From corn to soy to canola oil, a lot of agricultural products are genetically modified. A great example, in my opinion, is papaya coming from Hawaii. So once upon a time, in Hawaii, papaya production nearly became obsolete, like totally disappearing, because of a virus wreaking havoc on papaya plants. Genetic modification was used to provide resistance against this viral pest, and now we can have papayas from Hawaii again because of genetic modification.
But we can't avoid the elephant in the room forever. We've got to acknowledge the fact that the topic of GMOs is highly controversial, especially when it comes to eating them. And people tend to have really strong opinions either for or against these products. Maybe that's even the reason why you're tuning into this podcast right now. Many people who are wary or downright angry about GMOs are concerned about either the impacts of GMOs on human health or on the environment.
Okay, well, why don't we start with human health? Can GMOs be threatening to consumers? Well, let's look at the scientific literature. As we mentioned in episode 26 of the forum, scientists have now looked at about 29 years of data on the health of livestock that have consumed genetically engineered feed. And this data includes health info from before and after the introduction of GM feed into the diet.
The result was that the genetically engineered food had no impact on the health or well-being of the animals. Considering that we often use animals as models when deciding whether things like pharmaceuticals or cosmetics are safe for human use, it can be concluded, based on these 29-year studies, that GMOs are safe for human consumption.
Right, and of course, longer-term studies are still underway.
Right, of course.
And so now we can bounce over to the environmental concerns. Environmental concerns about GMOs can be divided into two categories, really, so we'll tackle one at a time. The first one is the worry that GM plants will either crossbreed with native plant varieties or just outcompete the native varieties in nature.
And in our next section on regulation, we'll talk a little bit more about this. But when it comes to this environmental concern, it's important to recognize that the potential for crossbreeding with natural species or for survival outside of cultivation is assessed prior to use in real-life farm settings. And it's continuously monitored even after we start growing the GMO.
Not to mention that studies suggest most GM varieties actually tend not to survive well outside of cultivation conditions. To be fair, though, we can never rule out environmental cross-contamination 100%, but we can take steps to minimize the chance of environmental dangers actually coming to fruition. Now, the second environmental concern is that GMOs might negatively impact non-target organisms. So, for instance, someone might worry that a gene conferring resistance to, aphids or something might accidentally actually end up killing an entirely different insect species.
And perhaps some of this concern comes from a 1999 study performed in a lab, which said that pollen from insect-resistant corn could negatively impact monarch butterfly larvae. But after this concern was raised, a bunch of follow-up studies, both lab and field studies, were performed and published in major journals like PNAS and Nature, and they concluded that no such impacts were actually observed.
And just so both sides of the story are represented today, don't forget that many environmental benefits can also be tied to GMO use. For example, a 2015 study reported that over the first 19 years of GMO use, the amount of pesticide chemicals used decreased by 581 million kilograms. And if plants are engineered to have higher yields, we would need less farmland to grow equal amounts of food, which is obviously good for conservation purposes.
In the end, when it comes to practical concerns about GMOs, we need to analyze the data and recognize that we have a cost-benefit analysis problem on our hands. What risks can and should we be taking as we try to address major societal problems like food production in a climate insecure and population-heavy future? What's the appropriate level of risk for us to accept? And how do we make sure greater risks aren't actually taken? Well, Daniela, I think this actually leads nicely into your section since we currently use regulations to address some of these questions.
Yeah, who actually regulates GMOs so that they can actually be used?
Well, that really depends. Regulations differ around the world, and because GMOs themselves are a really controversial topic in the public eye, the levels of regulation vary widely. For example, compared to other countries, particularly Australia and New Zealand, crops grown globally, but mostly within the US, account for 69.5 million. And so you can see that in the US, actually you have a very favorable culture for GMO development.
Yeah, because GMOs are an economically important component of the biotechnology industry, which now plays a significant role in the US economy. The US is currently the world's leading producer of GM crops. In 2012, of the 170.3 million hectares of biotech-related crops grown globally, the United States accounted for, get this, 69.5 million, which is over 40% of the total.
Right, exactly, over 40%. And when it comes to several crops grown in the US, genetically engineered varieties now make up the vast majority. In 2013, for example, 93% of the soybeans, 90% of the cotton, and 90% of the corn grown in the US was genetically engineered for either herbicide tolerance or insect resistance.
Okay, so you're saying that US regulation is not very strict when compared to other countries?
No. That's not what I'm saying at all. Let's not give our audience the wrong idea. While it is true that the environment over there in your neck of the woods is conducive to development, safety regulations are still strict and effective and safe. The main two differences, I would say, that make the US stand out are one, the fact that its regulatory system is product focused rather than process focused, and two, the fact that the US puts GMO plants in the GRAS category, or what the FDA calls generally recognized as safe, GRAS.
Yeah, so the United States doesn't have any federal legislation specific to GMOs. Instead, they're regulated under health, safety, and environmental legislation governing conventionally bred food products. And for those of you just waiting to jump in about CRISPR-Cas9 or gene editing, we'll get back to that later, I promise.
Anyway, what I meant by product-focused regulation is that it's based on evaluation of the end product that is genetically engineered. The process itself of how the product is made, so genetically engineered or conventionally bred, doesn't influence its regulation.
In other words, let's say you genetically engineer a potato to have thicker skin. You can compare that GM potato to another potato that was conventionally bred over a few decades to have the same thick skin. Regardless of the process, because those two products are genetically identical and share the same DNA, they would go through the same regulatory process in the United States.
Okay, and am I right when I say that this would be overseen by the US Department of Agriculture, or, the USDA?
You certainly could be, but it really does depend on the type of organism we're looking at. GMOs are regulated in the US under the Coordinated Framework for Regulation of Biotechnology, published in 1986. Under this framework, there are three main genetic modification regulatory bodies in the US. The US Department of Agriculture, USDA, like you mentioned, the Food and Drug Administration, FDA, and the Environmental Protection Agency, EPA.
Right. So plant GMOs are regulated by the USDA under its Animal and Plant Health Inspection Service, or APHIS, under the Plant Protection Act.
Exactly. And APHIS grants authorization to implement GM plants in three different ways. First, the notification process. Second, the permitting process. And third, the determination of non-regulated status. And to avoid being unnecessarily jargony with this whole issue, the key point you want to understand is that all applicants aim to get to determination of non-regulated status eventually. GM plants that have been tested and don't pose a safety risk may be eligible for this status.
So that's the basic structure of the USDA's regulatory reach?
Exactly.
But what about the FDA's?
Good question. Well, we mentioned before, really, that under the FDA, plant GMOs are regarded as safe and therefore treated in the same manner as conventional plants, unless otherwise noted. That said, we should mention really quickly that this only pertains to plants. GM animals must undergo way more extensive regulation and risk evaluation, but that is totally a topic for another day.
The FDA also encourages developers of new plant varieties intended for food use, including GMOs, to engage in a consultation procedure with the FDA in order to ensure that safety issues are resolved prior to commercial distribution. And the FDA makes detailed information regarding completed consultations publicly available, which is super awesome because it's so transparent.
All right, so finally, the last regulatory body, the EPA. What's their role in this whole thing?
Well, okay, under the Federal Insecticide, Fungicide, and Rodenticide Act, or FIFRA, the EPA regulates plants that are genetically modified to produce substances intended to control pests. The regulation actually doesn't differ from the standard registration procedures for regular old pesticides. And for those of you concerned about the environment, the EPA sometimes even requires environmental impact statements if the product is likely to significantly impact the environment.
So, now that we've chatted about the US, why don't we talk about regulations in the other two countries we're live streaming from for today's Synbio Live conference? What's the deal in Mexico, for instance? Shout out to our collaborators in Guadalajara today. Hey, guys.
So, Mexico's Department of Health has approved about 130 GMOs for human consumption so far under Mexico's law on biosecurity of genetically modified organisms, which is the main federal law regarding GMOs. And, unsurprisingly, its main goal is to reduce or prevent risk through a 5-step evaluation process.
And the law is pretty strict because if you break it, you could actually face up to 9 years in prison.
Wait, why do you know that?
No reason.
Well, now that Cleo just, implied that she's been in jail in Mexico, I'm just going to move right along. So, nationally conducted studies and resulting data on GMO risk must be presented to Mexico's Department of Health for analysis and review. If the review finds no evidence of risks to human health, the GMO may then be approved by the Department of Health for commercialization and importation purposes.
And once the GMO is approved for human consumption, it must be labeled in the marketplace for its nutritional value and ingredients.
But we'll talk a bit more about labeling later on in the show, I promise.
Yeah, actually, labeling regulations in Mexico seem to be pretty similar to the regulation over here in the UK.
Oh, right. I almost forgot for a second that, you're not here with us, Daniela. Why don't you tell us about what's going on over there? What's the regulatory attitude like in the UK for GMOs?
Well, it's actually a super interesting time for GMOs because of yesterday, Brexit. Most of the regulation that the UK has historically developed regarding GMOs comes from the European Union, but independent UK regulation regarding GMOs post-Brexit is still actually in development. Historically, though, alongside the EU, the UK has taken a strict position when it comes to GMO regulation. Only one GM crop has ever been approved and cultivated in Europe, which was a weevil-resistant strain of corn.
Yeah, the EU actually has really strict regulations on GMOs, and this includes food and feed from GMOs. The EU's GMO legislation is based on the precautionary principle and reflects concerns expressed by skeptical consumers, farmers, and environmentalists.
GMOs can, however, be marketed in or imported into the EU, provided that they're authorized after passing strict evaluations and safety assessments imposed on really a case-by-case basis.
And while this is regulated at the EU level, the cultivation of GMOs is an area left to the EU members. EU members have the right to prohibit or restrict the sale or cultivation of approved GMOs based on adverse effects on health and the environment.
In terms of labeling, in the EU, if a food consists of genetically modified organisms or contains ingredients produced from GMOs, this must be included in that label.
So I don't know if you guys noticed, but it's pretty late over here in the UK. The lights are out. I'm just going to keep going. So anyway, yes, it has to be labeled, unless the presence of approved GM material on non-GM food is accidental. And in this case, the threshold to not label is set at 0.9%.
So both the UK and Mexico require this GM labeling. Did we talk about US labels?
Actually, no, we didn't. I guess we skipped right over that. But Cleo, you're way more savvy on this topic than I am. Do you want to fill us in?
Yes. Okay, so I'll definitely fill everyone in on this. And you all out there are probably wondering at this point what the deal is with US labeling laws. And hopefully we'll deconvolute some of the confusion for you today.
And to start, I think it'll really help if we give everyone some pros and cons associated with labeling, foods that have GM ingredients, so that we can have a better understanding of why this has been such a huge topic of debate.
Totally. So first and most likely foremost, we've got consumer knowledge. If you walk around and you ask people if they'd like more info on where their food comes from or what's in it, chances are they're going to tell you yes, they definitely want this information. After all, if you're a vegetarian, but the tomato you're eating has been modified with the gene of a pig, a lack of knowledge might cause you to unknowingly cross some moral lines.
Yeah, and I think because of reasons like this and surely others, some also just believe this knowledge is a fundamental right of the consumer. If we're putting this food into our bodies, we should know whether or not it's been made through genetic modification techniques. That's their rationale, plain and simple.
Except it's nowhere near that plain and simple. Labeling is expensive. It takes an average of $136 million to develop any given GE crop, 35 million of which goes into regulatory costs. So labeling the foods would further contribute to the millions of dollars spent on a regulatory process that a lot of scientists believe is unnecessary and can be streamlined.
Yeah, so crop biotechnology has been dominated by really only a handful of big companies, in large part because of these super high costs. Try being a university scientist and asking your department for $35 million casually. I mean, some labs are having a hard enough time funding their grad students these days. I could tell you stories about colleagues who've panicked about not getting fellowships because they thought their advisors couldn't pay them.
I think maybe we should stay on topic and rather you didn't.
Fine. You don't want to be depressed today.
So, of course, expenses associated with GMO regulation and labeling can stifle the ability of smaller companies and university breeders. But another con we see is the cost impeding the genetic modification of less common crops. For instance, let's say something like asparagus could help solve hunger. But chances are we'd never know if the cost of regulations are so high and there are too many regulatory hoops to jump through. And all of these regulatory and labeling costs will most likely translate to increased costs to the consumers. And as is the case with most price spikes, it's likely that the poor get hit the hardest here.
And another major concern is how such a label might be perceived by consumers. And this is where we could get into a whole other conversation about the importance of science communication and consumers educating themselves with reliable sources of information. But we're going to try to keep it on topic.
Yeah, you were about to tell me I was getting off topic, Dee.
All right, so on topic is probably a good point. So it turns out that scientific peer-reviewed studies have shown that prominent mandatory labels, like the ones proposed for GM foods, mislead, scare, stigmatize, what have you, the consumers, who see these mainly as warning labels. And this is a big issue because it may steer people away from purchasing foods that are in fact safe to consume, thus destroying the market for technology that could play a major role in feeding hungry people around the globe.
So for all of these reasons, the AAAS, aka the largest organization of scientists in the US, actually does not support labels. And they've actually stated that, quote, legally mandating such a label can only serve to mislead and falsely alarm consumers, end quote. Whew. Now, this may seem like very strong language over something as seemingly simple as a label, but it's really a big deal. So big, in fact, that a GM labeling law was signed into action in June of 2016 by President Obama.
Wait. So this bill is already in effect? Why am I not seeing these labels on my foods when I visit friends and family in the US?
Well, this is where our GMO story gets particularly sticky. So, although we can truthfully say the phrase signed into action, a more accurate description of where the bill is now is that it's leaving the legislative period and embarking on the regulatory and marketplace phases. In these phases, the bill directs the USDA to begin the process of deciding what exactly food manufacturers will be required to label, which is not as easy of a task as you might think.
Right, because the USDA now has to figure out how to define which ingredients actually count as genetically modified.
And I'm guessing this is going to take some time.
If by some time you mean literal years, then yes. Figuring out the exact language of the law and how it'll be interpreted and put into practice will most likely go on for years. The only sure-ish deadline we have at the moment is that the USDA is supposed to complete their part of the deal within 2 years. But back to the bill itself. Technically, the food product that's being labeled must have genetic material that would identify it as coming from a genetically engineered source in order to get this label. Sounds easy enough, right? Wrong.
Wrong indeed. And to give you a little snapshot of the complexities of this decision, here's an example. The bill gives the USDA the authority to include in this definition of GE food all commercially grown GMO corn, soy, canola, and even sugar from sugar beets. That could also mean that any food made from the oils or sugars that come from something like GMO corn could be included in the labeling requirement. And this includes high fructose corn syrup, which, as I'm sure you know, is basically in everything these days. However, as if tracking all the original vegetables for oils and sugars that make up a product wouldn't be hard enough, some products are so refined these days that they have little to no GE DNA even left in them.
So things like soda would be in this category.
Exactly. The USDA now has to figure out if it's worth it or even ethical to still label these products. The agency very well could choose to exempt products that only contain a small fraction of GMO ingredients.
Oof, well, that seems like a whole battle with pro-labeling groups just waiting to happen.
You're not kidding.
Just wait, though. It gets more dicey here shortly. Another piece of this bill that's already fueling the fire for more battling is how the foods are going to be labeled. Companies have three choices for this step. They can add text to a label stating that it contains GE ingredients. They can put a yet-to-be-determined symbol on packaging to denote such ingredients. Or they can use a QR code or a quick response digital link that consumers can scan with their smartphones.
So, besides the fact that QR codes are so 5 years ago, wouldn't QR labeling just exclude all the people who don't have or can't afford smartphones?
Oh, totally. Which is why a lot of pro-labeling groups are up in arms about this one. But even the other options are kind of confusing because it's so incredibly difficult to tell what makes up a GMO these days. As it stands, the bill's language describes GMO foods as foods that contain genetic material created through in vitro recombinant DNA techniques, what Aubrey was talking about before with the bacteria that I can't pronounce. But when ideas for this bill came into fruition close to a decade ago, this description was pretty sufficient.
Right, but things are a little bit different now. Only labeling foods made with in vitro recombinant DNA techniques might actually exclude a whole bunch of GMOs. And this is because scientists have now figured out new ways of modifying genes by gene editing.
So gene editing, while falling under the umbrella of genetic modification, would not fall under what's covered in this bill. And because she has the most background in the hard sciences out of the three of us, I'm going to let Aubrey hash this one out for you.
Okay, my turn. Okay, so gene editing, including techniques like CRISPR-Cas9, gives us the ability to snip and tweak DNA at very precise locations. Unlike usual GMOs and the ones covered in this particular bill, this gene editing technique is generally not used to add genes from other organisms, but rather to turn off certain genes within the plant or turn others on. In fact, if DNA is added at all, it's usually from the same species, so there's no way that that DNA is actually considered foreign by any means. And gene editing doesn't even involve using bacteria to perform the modifications to begin with. So it's really very different from the, GMO techniques we've been talking about all day.
And thus, you can avoid labeling laws. Gene editing techniques also fall largely outside of current regulation in general. So it's not just the labeling part. Companies use gene editing, submit their data to the Federal Agricultural Department, and are given the green light when their data shows no introduction of foreign genes. In fact, hundreds of acres of gene-edited crops have already been grown in several states.
Like those white button mushrooms, right?
Oh, yes, and thank God, because I love those.
Yeah, same, actually.
All right, you guys. So, what does this mean for regulation and the current labeling bill? Well, honestly, no one really seems to know yet. Federal agencies are totally unsure of how they intend to regulate these technologies.
So, obviously, we're already running into some major issues here. If some people decide and designate gene-edited crops as GMOs, but others don't, and if some of these crops are regulated while others aren't, then the oversight process quickly becomes even more convoluted, confusing, illogical, what have you, than it already is.
Which is, pretty hard to imagine considering all of the, regulations we talked about today. But speaking of confusing, what's the deal with Vermont's labeling laws? Didn't they do something pretty official related to the whole GM food labeling thing?
Yep, they definitely did. So as of July 2016, Vermont's controversial rule required labels on or near various GM foods, though manufacturers were given a few months grace period to get into the swing of things. But the federal labeling law actually overturns the Vermont one, which of course many people in Vermont are less than happy with. And it's mainly because requirements that they had were generally stricter than the national ones.
Well, Then where do you think we're left when we think about the future of GMOs in our food supply? This bill was signed by Obama, but in case you somehow missed it, we have a new president now in the US. So what does this mean for genetic modification?
That's a great question, actually, and I would love to be able to answer it. Unfortunately, we really don't have a lot of information on President Trump's stance on these technologies, including whether or not we should be labeling.
Alrighty, so I think we've given everyone lots to think about today. And if you've listened to any episodes of the forum before, you might know that we like to end our show on a few questions for you to ponder. And today's no exception. So I'm going to loop back to the science side of things, and I'll ask you, with hopefully a better understanding now of the science and rationale behind GMOs, do you feel comfortable eating them and exposing the environment to them?
Do GMO-related regulations need to be made more uniform across international borders?
And do you support GMO labeling? If not, what's your reasoning? And if you do, what should the labels include to be useful? You can tweet us your thoughts at ISGP Forum with today's hashtag SynBioLive.
And if the GMO theme is of interest to you, let me just take a second to direct you to 3 past episodes of the forum which deal with this topic. These are specifically episodes 9, 19, and 26. All you've got to do is go to soundcloud.com and search ISGP's The Forum to find these and our other episodes. Also, if you're interested in having conversations about GMOs and other Synbio topics, we definitely encourage you to check out a digital kit that was produced by the Building with Biology project. This kit really helps with these conversations by providing activities that you can print out at home. In fact, one of the kit's activities, called BioBistro, is all about GMO foods like we've been talking about today. We'll link to this kit, over on our Facebook page, facebook.com/ISGP Forum, but you can also find it by going to buildingwithbiology.org.
Yeah, and I've actually looked at the Building with Biology toolkit myself. It's pretty cool. I think they use it at science museums and stuff.
Yeah, they definitely do.
So before we sign off today, let me remind you that the next session of today's event, Being Human 2.0 Synbio Live, will start very shortly around 3:30 p.m. Eastern Time, give or take, for Daniela to get set up.
Yep, so that's about 8 minutes to set up, but I'll be interviewing Dr. Richard Kitney from Imperial College London about clinical applications of synthetic biology. We'll be streaming the interview live on facebook.com/ISGP Forum, and I really don't think you're going to want to miss this one.
Alrighty then. Thank you so much for tuning into our live ISGP's The Forum podcast. And of course, thank you so much for socializing with science today. We hope you enjoy Synbio Live, and we'll catch you next time right here on the forum. Bye, guys.
Bye.
Bye.